What's up guys, Sean King with Mr. Fitz Academy. Let's talk about gates, right? Not just any gate, let's talk about wood gates. In particular, wood gates without steel frames. Can you build a strong wood gate without a steel frame that is resistant to warping? Let's find out.
We need to stop building fence like Granddad and start building fence like our kids will need to in the future.
This is Mr. Fitz Academy. With gates, let's talk about some things to consider first with gates. The most important thing to think about with a gate is which side of the gate to put the hinge on. Okay, this is very important. The hinge needs to, almost must have, be on the downhill side. In other words, in this, the ground sloping away from the house, so in this situation, my downhill side's to the right. Not by much, but this post is lower than this post. So this is what we call the downhill side. So this becomes the hinge side. It's very important that we make that the hinge side. If we make the uphill side the hinge side, and we open this gate up with the hinge uphill, it's gonna hit the ground. I see this all the time when I drive by and see other fences because a homeowner asks for the gate to swing a certain way and it doesn't work. It opens up part way, okay? So when you build a gate, I want you to be thinking the most important part is, where's my low side? Boom, got it. Now at that point, if you have to swing it in, there's ways you can swing it in, but today we're gonna swing this gate out. I believe we'll clear this grass here because it does go uphill away from the gate, but we have enough room to clear this and swing the gate out, so we use a traditional T-hinge on this gate setup, okay? So most important thing is, what side do we hinge the gate off of? Cool. The next part that I see oftentimes, what direction to put the brace in. Everyone knows there should be a brace in the gate. That's pretty common. No one argues with that. But we see different types of braces and different configurations of those types of braces, okay? Brace is in there to counteract gravity. That's what we're trying to do. We're trying to react towards the gravity forces acting on the gate. So that's the whole purpose of the brace, to prevent the sagging. Gravity's pulling down on the gate. There's two types of braces, period, that I know of. That's compression or tension. We're gonna get to some physics here for a minute, but compression and tension are the only two types of braces that I know of that exist, all right? So a compression brace is resistant to gravity. It's pushing against gravity, okay? That's the easiest way to think about it. A tension brace is pulling against gravity. So a tension brace is pulling and a compression brace is pushing. Which one's better? Which one's stronger? Tension, I would say, is technically stronger if and only if you have a superior connection, all right? So the weak link in a tension brace is the connection. So with a metal brace, like a metal frame chain link gate, where the brace is welded, can we agree that's a superior connection? Some welders will say the weld is stronger than the material itself, right? So the material itself will tear, okay? So we have a superior connection, so tension's great. In wood, can we weld wood together? So if we use wood, now we're trying to screw a connection together, right? Do you think that's a superior connection? It's probably not a superior connection, right? But if we put wood in compression where gravity's pushing against the connection, it's different. We're going to compression, okay? So in a wood brace, we want to use compression so we're not relying on the screw that's pulling on the tension brace, okay? So to be in compression, that means that the brace needs to be from the downhill hinge side and up to the brace. So in this case, the brace would run from down here up. Gravity's forcing down. It's pushing the energy into the brace. The brace is directing the energy back to the bottom hinge, okay? Gravity's pulling down. Now if I was to put this in tension, that would be from here to here. Gravity's pushing down and tension's pulling up. A cable, like a turnbuckle or something, would be a tension brace, right? So here we go with the famous straw. This is gonna help you understand bracing. This is gonna be my brace. Okay, so how do I put this brace in tension? How do I make this brace become tension? How do I do it? Pull, right? Okay, anyone think I can tear this straw in half? So if I pull on this, what's gonna happen? What happened? Connection failed. Tension, the weakest link is a connection, right guys? So I'm pulling, you see that? I cannot tear this in half, I can't stretch it. The connection is the weak link, right? Now if I push on this, is that compression? Now what's gonna happen? Is the connection gonna fail? What's gonna happen to the straw? Okay, so we gotta think about when we were in compression, do we have a brace that's stiff enough to resist the forces before it bends, right? I'll give you for instance, in vinyl fence, I see people put a 3-inch by 1-inch vinyl picket in a brace, in compression. What happens when that has load on it? Is that brace gonna flex? If that brace flexes at all, the gate will sag. But if you take that same vinyl picket and turn it in tension and have a good connection, it will not sag. Does that make sense? Okay, so today with a wood gate, we want to be in compression so that we're pushing on our connection. I don't believe these 2x4s are going to buckle under the weight of this gate. Do you agree with me? You follow the science behind why we use tension and compression, why we use compression on a wood gate? It's pushing on it, okay? So we're going to use a compression gate or a compression brace. The weight is pushing down and on it. Here's the next really, really important piece. Your compression brace cannot exceed 45 degrees from plumb. Here's plumb. 45 is halfway to grade, right? So 90, 45, 0. You with me? All right, it cannot exceed 45. 46 is no good. 47 is no good. 50 is no good. You understand why? It's a leverage thing, okay? So if I have a brace straight up and down, do you guys think you can support your weight by sitting on top of this? Would this support us? It would. My weight doesn't support my weight. But if I turn it out of the way down here, what will happen if I put weight on that? It'll go straight to the ground, right? Okay. At 45 degrees, we got 50% of the energy going to the brace and 50% of the energy going to the ground. We're net zero at that point. We've now negated all of the energy. Okay. 42 degrees, we have more of the forces going to the brace or to the hinge than we do to the grade. The degree is very important. And this messes people up when they have a 5-foot and 6-foot wide gate. They believe it needs to go from the bottom hinge, like I said, to the top of the gate over here. Let's say the gate's over here. And they got this big long angle. It becomes over 45 degrees and the gate will eventually start to rely upon all the connections, like the nails everywhere, and once those start to fail, the gate will sag. Okay? So key thing is less than 45 degrees from plumb. How do we figure that out without using a compass or protractor or a square or all that stuff, right? Real simple. Geometry tells us that equilateral triangle, these two distances are equal length in a triangle. This creates a 45-degree angle. Okay? So my control point is my distance from where my brace starts to where my brace finishes. I cannot exceed that dimension from here to here. So for instance, on a 4-foot gate, it's never a problem. This is a problem on 5-foot wide gates. On a 4-foot wide gate, my dimension between these rails is 50¼ inches for our style fence. 50¼ inches. So 45 degrees, I can go 50¼ from here to my brace. Well, 50¼ is all the way over here. I won't be that far. So anything less than that makes my brace even less on 45 degrees. So I don't have to worry about it. It doesn't matter. But on my 5-foot wide gates, I need to stop at 50¼ and let the gate continue on. So my gate brace would, let's just say this is 5 foot wide, and my 50¼ stops here, my brace stops right here, and the gate continues on. All right? We don't want the brace to go to the very end. We want to stop there. This 1-foot cantilever is not going to sag. That 1-foot 2x4 is not going to droop. All right? If you end up with a really wide gate, a person could put multiple compression braces in there, yes. But that gets into a whole other ball game. I wouldn't suggest gates any wider than 5 foot. If you're building a 6-foot gate, you might want to add a steel frame or some really beefed up framework because the wood itself starts to give away. Does that make sense? So compression bracing, tension bracing, we're using compression today, less than 45 degrees. Gate bracing 101, there it is.